And so now we're going to turn back to the fellows. So you might notice that Neil Park is not, unfortunately, standing up here. He missed his flight coming from New York and so is unable to join us. Luckily for him, his partner, Ginny, happens to be presenting later on her own project, and she generously volunteered to take it over and to present Neil's as well. So we're going to turn it over to Ginny, part one, for her project. So.
Thank you. Hi, everyone. I am not Neil Park, but Neil is one of my collaborators, as is Brandy Noneke, on this project related to test-driven development for technology policy. There was a great question earlier that was about how do we have more trust in the policymaking process? And Nicole's answer to that question was transparency. We need more transparency in these systems. And our project addresses that. Many of the projects you'll see from the Hub today are about how do we change policy, and our project's about how do we change the process of creating technology policy. So the goal of our proposal is to help make technology policy more robust. And what we mean by robustness is that technology policy would ensure that the policy actually addresses the problem of interest and that it avoids unintended consequences. The way we propose we will do this is by applying principles that are used to develop great software. So why would one apply the principles of building software towards the process of building policy? And we actually think that code and policy have a lot in common, and so actually there's an analogy here that we could convert into some process actions. So code and policy are pretty similar because, one, they both introduce new rules within an existing complex system. Two, they are both built to handle a range of possible conditions, and these conditions can be really hard to anticipate. And finally, both code and policy need to work every single time. Software has had moments of needing, as an industry, to reform its processes to make software more reliable. And actually, in 1968, NATO convened a conference because there was a software crisis. The crisis came because computing systems were developing really, really fast, and computing power had gone off the charts, and software engineers were having a field day of coding and coding and coding, and things were just breaking. The code was spaghetti. It was really hard to have software that was reliable in any way, and a bunch of systems were going down. And so NATO convened a group to say, as an industry, we need to come up with better processes to make our products more reliable. And it was out of that testing frameworks and a process called test-driven development became a backbone of how software is and continues to be built. And so test-driven development relies on testing every line of code you write. What is a software test? Here's an example of what it would look like to test a phone number. So imagine you're a software engineer, you're building a form in which people would need to insert their phone number. And we would want to take a lot of different kinds of phone numbers, right? We would want, for the first two examples, we would want both of those formats to be processed, but we wouldn't want an invalid format processed. We wouldn't want a UK number to be submitted if it's a service for US citizens only. We wouldn't want letters to be submitted for a phone number, for example. And so as an engineer, as you were writing code for this, you would actually first come up with all the examples. You would say, okay, these are examples of phone numbers we would want to work, and these are examples of phone numbers or non-phone numbers that we don't want to work. And you would write tests. This format works, this format shouldn't work. Then you would write the code. And you would write a little program about taking in the phone number, and then finally you would run the test and you would confirm that the program you wrote satisfies the conditions and specifications you laid out first. So here's a little graphic of just how that process works. But what could it mean for policy? We're proposing that you could write policy tests. And these tests would not be code, they would be words, they would be text, and they would be examples of concrete situations that policy is or is not supposed to address. Instead of code, what you would be writing in response to the test would be actually policy language, drafts of new policy. And then running the tests, which for software engineers is done completely by the computer. Running the test in our case would be actually a process of sitting down and using your concrete example and using the policy you wrote and seeing if the result from the concrete example actually matched what you intended when you ran it through the policy you had drafted. So we're going to walk through an example, a case study of how this might work concretely. And that is a new act called the DETOUR Act, which Senator Warner and Senator Fisher jointly introduced. And this act is about dark patterns. A dark pattern is a manipulative online marketing practice. And this act is about how do we make illegal online marketing practices that are created to deceive users. So for example, this bill might want to make illegal this concrete example, which is you would agree to the terms and conditions without actually seeing them. Or like it's kind of hard to click in and see them. Or my favorite example of what would be illegal is putting a fake hair on an ad so that people tried to swipe the hair off of the screen of their phone and then they click into the ad. I know, I wish I was in the meeting where this idea was come up with, because some companies actually do this. But we want to make this illegal, for example. But what we would like to still be legal is this perfectly normal, everyday ad for the New York Times cooking section. So how would we design tests? Designing tests is a creative process. There's no formula, there's no set way that you can necessarily just have the test spit out. And it's a creative process that will require a lot of brainstorming and collaboration, but we believe that there are patterns of the types of tests one could write to ensure strong technology policy. And we've created a long table, much longer than this, of what we call categories of tests. The questions you would ask to arrive at that category of test. And then finally, examples to make a little bit more concrete what we're proposing. So for example, in the subcategory, the second one on the list, the subcategory test, let's pretend that we're writing a content moderation policy. And in that policy, we would like nudity to be illegal. So you can't post nude photos on Facebook, for example. So tests that we might create to see if our policy is functioning as expected is we might have an example of a clip of pornography and an example of a nude in art. And we would want the nude in art to pass and be allowed, and we would want the pornography to fail and not be allowed. So these are some of the types of tests that would come out of this. And then the benefits of this process, we believe, and of the continually iterating over examples, are ensuring that policymakers consider a range of examples in advance. That writing tests is actually a lot easier than writing policy. You don't need to be a lawyer to write tests, so it's a way to engage industry experts as well as the public. And then finally, tests can be used flexibly, and you could only test certain parts of the code of the policy that are particularly murky, or you could use tests to ensure the thoroughness of your entire policy. But this philosophy can be used in part to make stronger policy. It doesn't need to be a huge effort or a complete redo of the way policy is made. So that's it for us. Thank you.
Questions for Jamie?
Thank you. I'm a software engineer. I use test-driven development every day. I tend to use it to build my code. I write my test first, run it, and then I continually run the test over and over. I'm wondering if there's some sort of analog, how do you run the tests?
Yeah, it's a great question. Also, I applaud you for being the type of engineer who writes tests first, because throughout my software engineering career, I have never done that, though it is what you're supposed to do. Often people will write code first and then they'll write the test. So anyway, you're much more of a purist than I. To your question around how do you actually run them, the way we imagine this happening in the policy context is having meetings where all of the collaborators on the policy come up with, read the test and say, for example, nudes and artwork, we would want to allow that, and read through all of the specifications of the policy and just manually imagine, based on what we have on this page, would it be true that nudes and art would be allowed but pornography would be banned, for example. So it's less rigorous than software testing, in which a computer will definitively tell you yes or no for sure. But still, we believe the process of coming up with examples and considering those examples alongside a final draft of an actual policy document would be an improvement and a way to utilize concrete situations in the policy that's created. Yeah.
Hi. I was wondering, how would the Thank you. Hi. How would the process deal with ambiguity? So a lot of policy ends up getting tested or interpreted in the courts. So you might have a range of different outcomes rather than this is legal or this is illegal or whatever under the policy that's being tested.
No, it's a great question. I believe that for some of the more ambiguous parts of policies often still have language. So for example, one of the other fellows, Aloni Cohen, had his whole project about the term probabilistic identifier and making sure there was more thoroughness around what a probabilistic identifier was in the California Consumer Privacy Act. So what we're imagining is you could write tests that help define in a more specific fashion what a term like that's a fairly broad term that could be interpreted in a lot of different ways, that what a term like that would mean, and publish in advance, these are examples of what this would cover, these are examples of what it would not cover. And so when the policy is made live, those ambiguous sections, though still clearly there will be ambiguity, there are at least a few concrete examples specifying how it was meant to be interpreted.
Awesome. We'll have to leave it there. Thank you, Ginny, part one.